Okay, the next step is to put the main pulley back on. So I've already done this, but it's pretty explanatory how to do it. Just remember to put the key that fits in the groove in the crankshaft and in the main pulley in. Slide the main pulley on, and then put the special bolt in with the washer tapering inward. But you should remember that from when you took it apart. Then the bolt gets torqued to 83 foot-pounds. So if you don't have a impact wrench that has auto torquing on it, then just get a friend to put a lot of pressure on the brakes and with the car in gear, and then you can tighten it up that way using your torque wrench. 83 foot-pounds. Okay, with the crank pulley back on, the next step is to put the valve cover back on. Again, pretty self-explanatory. Just loop it under the harness protector there and set it back on. Make sure that you've removed your cam pins and that there aren't any loose tools laying around on there before you bolt it down. Last thing you want is a tool to get left in the engine. It happens. Also, just make sure that your valve cover gasket is seated into its groove properly, and that you put it down nice and evenly on all sides so that it doesn't cause the gasket to ripple in any places. And then torque each one of the crown nuts down to 7 foot-pounds, and do them not one at a time, but finger tighten each of them and then tighten them a quarter turn each to bring it down nice and flat to get a good seal. Alright, the next step in our reinstallation is to put the ignition wires back in, connect them to the spark plugs, snap the PCV valve back into the valve cover, clip the blow-by hose back on, and bolt down the engine wire harness protector. This one right here, and can also connect the leads and the plug back up to the alternator. Next we need to get the alternator and power steering belts back on. That's fairly self-explanatory, so just loop the alternator belt first around the pulleys. So if you have air conditioning, it would go around the air conditioning pump as well, and around down over the main pulley. And then the same for the power steering belt, down around the main pulley. And then after that we'll do tension adjustment. Okay, so I put the alternator AC compressor belt back on, as well as the power steering belt. But I just want to say a quick note about tension adjustment on these belts. I think that, maybe many people might resort to the easiest way to do it, which is just to, kind of tighten them up until they're tight. And, quite tight, and then maybe take the car for a drive. If they notice some squealing sometime, they'll add a little tension and carry on like that. And I think that works, but the danger in taking that approach is that, if you're a little bit too aggressive up front and you do the tension of the belt up too much, then you might actually over-tension the belt, which is hard on the belt, and it's also hard on the bearing assemblies that are in your alternator, your power steering pump, and your AC compressor, etc. So Honda does actually list the deflections that can be used to make sure that these belts are installed correctly. Now, to measure the deflections, I think it starts with, something as simple as this, which is just a simple scale that you pull on, which you can use to hook to the belt, in the midpoint of the belt, and pull and get a particular force and then measure the deflection. So it's generally easiest to do this one at a time. So you'd put the alternator belt on, you would check it, get the tension adjusted, lock it in place, and then do the power steering belt, just so you have kind of room to work with your scale. So the belt deflections that you want to use, and all of these are assuming that you're applying a 10 kilogram force, so that's 22 pounds, is if you have, so for used belts, if you just have an alternator, no AC, then it's 10 to 12 millimeters of deflection that you want on the top stretch of belt that goes in between the alternator and the main pulley at the bottom. If you have AC, then you'd measure on that same stretch, so in between the alternator and the main pulley, but in this case the belt would also be wrapped around the AC compressor. Again, you're looking for 10 to 12 millimeters of deflection. Again, this is on a used belt. And then for the power steering, you measure in between the power steering pump and the main pulley, and it's 11 to 13 millimeters of deflection that you're looking for on a used belt. For new belts, those deflections are a little bit shorter because the intention is that they expect that the belt will stretch a little bit as it kind of wears in. And so the deflections for new belts, if you just have alternator, no AC, it's 8 to 10 millimeters on a new belt of deflection. If you have AC, then it's 6 to 8 millimeters of deflection, and for the power steering, it's 9 to 11 millimeters. And again, all of these deflections are assuming that you're applying a 10 kilogram or 22 pound perpendicular force. So the other thing to remember when you're doing your tension adjustment, for the power steering belt, you have to have loosened the bolt that goes through the tensioner pulley. Now that should already be loose because when you took it apart we loosened it, and unless you tighten it up again it should still be loose. And then you use the adjust bolt to pull it tight. And then when the tension is adjusted, you have to tighten that adjust pulley nut, or bolt rather, again. Similar for the alternator or alternator / air compressor belt, and the difference is that after you do the tension adjustment there, you want to tighten up the alternator through bolt, and that just helps to lock it all in place because you don't want the load of the belt, the tension in it, being borne by the adjustment system. Next we have to put the engine mount back in, and we're going to do this in the opposite direction or procedure that we used to take it out. So if you remember, when we took it out, we first loosened the nuts that held the engine side of the mount in place, and then took out the mounting bracket. So we're going to do the reverse of that, put the mounting bracket in first, and then tighten up the engine mounting nuts. So it's pretty simple. You have your 3 bolts that hold the bracket in place, and then the 2 nuts that hold the engine side of it up. And the torques, so the torque specification for the bracket side, so those 3 bolts, is 29 foot-pounds. And then for the nuts, it's 47 foot-pounds. So just put it back together as you had taken it apart and torque it up to those specs, and your engine will be remounted to that side of the car. With the motor mount back in and bolted up, and the bolts torqued to the correct spec, if your vehicle is equipped with cruise control, then you can put the cruise control unit back in place, bolt it back in place using a reverse of the procedure that we used to remove it, and then you'll also have to reconnect the valve cover ground. With everything back together, we're ready to get the car ready for startup. The most important part of that obviously is getting the coolant back into the engine, because as you recall we drained it when we were doing the procedure. The coolant that I use is right from Honda. I believe they call it Type 1. A lot of the coolants that are available at the auto parts shops and things like that, or off the shelf at your local hardware store, often include a lot of chemicals for inhibiting rust and things like that. Honda suggests that those type of products actually not be used in these cars because they have all aluminum blocks, and a lot of the components are aluminum as well. And so a lot of the rust inhibitive chemical isn't actually required, and can just end up gooing things up instead. That's not to say that any antifreeze probably wouldn't be okay, it's just I tend to go with what Honda recommends to keep the engine in as good a condition as I can. So I went to Honda and got coolant from them. They call it Type 1, and it's just a plain antifreeze coolant with very little rust inhibitors in it, and they've mixed it specifically for aluminum blocks. It doesn't come pre-mixed, so I will have to mix it. The way that you mix the coolant really depends on your climate more than anything, but for 95% of the applications, a 50-50 mix with water will give you what you need. I'm actually going to mix mine 60-40 coolant to water because I live in a particularly cold place and it does get below -40 degrees centigrade here quite often in the winter, and I don't want to run the risk of my block freezing up. You can use water from the tap when you're mixing with antifreeze, but it's definitely better to mix with distilled water. So that's not spring water or mineral water that you get at the grocery store, but actual distilled water that has no mineral content in it. The reason is that the water from your tap or mineral water or spring water that you might get at a grocery store in a jug will have minerals in it, and those will probably end up just accumulating on the inside of your water lines in the engine, and better to keep those clear. Distilled water is easy to find. I've had the most luck finding it actually at pharmacies, where you can usually buy it in a big gallon jug for, a few bucks. So I think it's money well spent to maintain the engine in good shape. Before I put the coolant in, I'm going to first put my splash guard back on and then lower the car back down so that it's on level ground when we do the fill procedure. Alright, to refill the radiator and the block with coolant, the procedure is pretty simple. The first thing that you need to do is go inside the car and set the heat control position all the way to hot. And then the next thing we're going to do is just go down here on the thermostat housing and with a 12mm wrench open up the bleed bolt, and that will allow us to see when the coolant has gone into that section of the block. So just open it enough that coolant will come out. You don't have to take it right out. Now what we're going to do is we're going to begin to fill the radiator up. Obviously that's pretty simple, but what we're going to be watching for is we're going to be watching for coolant to start flowing out of the bleed bolt that we loosened. And we're going to keep filling the radiator. When we see coolant running out of the bleed bolt, we're going to close it and tighten it up, and then we're going to keep filling the radiator until the fluid level comes up to the bottom of the filler neck. At that point, we'll start the car and we'll let it run until it warms up, or until the fan comes on twice, and then we add more coolant to bring the level back up to the bottom of the filler neck of the radiator. And as we do that, we're watching for leaks. As you fill, take what steps are necessary to prevent coolant from spilling on your paint, because it will wreck your paint. It's corrosive. Remember, you want to be using mixed coolant. So you can't put coolant in straight, it needs to be mixed with water. So as you fill, just watch that bleed bolt. And there, as you can see, there's coolant coming out of the bleed bolt, so we can close it. And just gently snug it up with your wrench. Then make sure the radiator is filled to the bottom of the pillar neck. And then start the car and let it warm up until the fan comes on twice. And then add any coolant that you need to bring it back up to the bottom of the pillar neck and close the radiator.